Hey guys, I got some feedback that said somebody did like my video, so I'm going to make another one. Let's look at a section 3 quiz. Ooh, some tough stuff in that little section. So this might be a longer video. We'll see. It also might be good to actually pull up some real problems out of the text, because these questions had a lot to do with graphing and domain and range and transformations. These are all difficult topics, so don't feel bad if you're struggling with this stuff. First thing I want to talk about is the concept of domain and range, which I know is troubling for many students. I'm going to draw something which does not go on forever. So one way to think about domain is like east-west on a map, right? It's so say you have the United States. I'm going to draw a terrible picture of the United States. Oh, and then there's what, Texas, there's the Gulf of Mexico, and there's Florida. You come up here, and by the way, this is the lower 48, not, I don't even know what's happening up there. And there's a straight thing, and then it goes over here. Okay, fine. So domain is like, how far west can you go? How far east can you go, right? It doesn't matter, whether I have to go a little north to get that east. I'm just thinking in terms of west and east. Range is thinking about in terms of north and south, right? How far north can I get? Well, I can get this far over here, but if I go over here, I can get a little bit higher, right? And down here, I can get down all the way to the tip there, so that's as far south as I can go. The question of domain is about east and west. And the question of range is about north and south. And so you want to go, as you're thinking about these questions, to the axis that you're considering. And in a way, kind of even just forget about the other axis. I think the x-axis kind of dominates people's mind and attention sometimes, right? But let me give you some numbers here, and I'll show you what I mean. So say this is, I don't know, -5, -3, right? And say this is 4, 7, right? So let's say this question says, hey, tell me about the domain of this function. So domain, east and west. So my mind, I'm thinking this is the only thing I care about. And I have this picture. And since this is the only thing I care about, this number, I don't even care about this number. Who cares what that is? And this number, who cares what this is? Right? And there's my answer. I'm going from -5 up to 4. That's the domain. Then the other decision I have to make is, do I use square or rounded brackets? And in this case, I'm going to use square because -5 and 4 are part of my domain. I can get to them, right? They're the filled in circles, so they are included, right? The square is included. And on your keyboard, it should be on the right side next to the P, right? You get the open and closed square braces. All right, then as I switch my attention to range, I have to switch my thinking to north and south. So hip, hop, hip. And as I'm thinking about these points, notice this is not necessary. And this is not necessary. Okay, so my range is -3 up to 7. Now, it just so happened that the way I drew it, it went in that order. If it went the other way and I started at a higher point and ended at a lower point, the range, we still write it from south to north, right? From the lowest to the greatest, because that's just kind of how our mind works, to go left to right, as we think from least to greatest. Okay, so this is the range, and this is the domain. All right. Well, I hope that helps a little bit with domain and range. It's not my idea. That was a colleague's idea that I really liked. Talking about domain and range a couple years ago. Okay, so let's talk a little bit about transformations. Transformations are tough, but a really critical concept in terms of the visualization of graphical representations. We'll start with an easy one. Y equals x squared. It's probably the first nonlinear thing you get introduced to, right? This idea that the output, I'm gonna write it in function notation here. The output is just the square of the input. So I take the input, I square it, and that gives me the output. So I have a mapping of things like 3 maps over to 9, and 4 maps over to 16, and -1 maps over to 1. Okay. All right. So transformations. So there's 2 tables that I think are important with transformations. The first table is the actions. And we have those linked to operations. So plus or minus is a shift. Okay, when I add or subtract things, I'm shifting my picture left or right, or up or down. Then I have multiply or divide. Well, that's a stretch or a shrink. Okay, so I'm taking my little parabola and I'm either stretching it or shrinking it. And that could actually be going both ways, right? Because I could take the arms and stretch them up, I could take the arms and stretch them out. And then lastly, times -1 is worth separating because it flips. And with flips, we can flip horizontally, we can flip vertically. Pearson, I notice, uses the phrase flips over the x-axis, flips over the y-axis. So I'm going to talk about that in a second. So this is one table you need in your head, that there's these different actions that come from the basic operations, adding and subtracting, multiplying and dividing, and multiplying by -1. Okay, then the next table has to do with x and y. So x is horizontal, obviously. Y is vertical. X has to do with the inputs, and Y has to do with the outputs. And X is counterintuitive, and Y is intuitive. Okay. So what I mean by that is this is really one of the most important parts. That the concept of what would happen is either intuitive, it's exactly what you would think it is, or it's counterintuitive, which means it's the opposite of what you would think. One last thing to put here is these happen inside and these happen outside. Okay, so what do I mean by this? Let's take a look at this and let's kind of break down the transformation concept. Okay, so I see 3 things, right? Because I'm starting with the basic concept is that something is squared. So that's my original function. I'm starting with a parabola. What else has happened? Well, I can see there's a ×2, I can see there's a +2, and I can see there's a -3. Now the parentheses mark the inside-outside boundary. So the +2 is inside, which means it's horizontal, it has to do with x, and it also means it's counterintuitive. That's important because normally if I was going to do +2, which is a shift, and I was doing it horizontally, I would think I'm going to take this thing to the right because adding 2 takes me to the right. But it's counterintuitive because it's inside. That means that +2 is actually going to be a shift left. Okay. Next, I'm seeing -3. -3 is outside, which means it's vertical, and it's intuitive. Okay, so I'm going to go down 3. Let me use a different format here to highlight my conclusions. This is down 3. This is shift left 2. And I just have one more, which is my times 2. Okay, times 2 is outside. It's vertical. And it's a stretch. So that's a multiplying by 2 would automatically make something bigger. It's a stretch of 2 vertically. Okay, I'm going to circle that. So I've got 3 things to do to transform this. I'm going to shift left 2. I'm going to draw this in stages here. So we'll go 1. So shift left 2. See, I already screwed it up. Shift left 2. Right? And to keep saying it out loud to myself to not screw myself up. All right. Then the next one, let's go green. This is number 2. Oh, no. It's fine. Draw. Boom. Green. Good. This is going to be my next one, down 3. I'm going to take my shift left and I'm going to go down 3. Oh, that's ridiculously bad. Okay. And last but not least, with some yellow, this is number 3. I want a vertical stretch. So I'm going to take this, I'm going to make it thinner than it was. Why thinner? Because it's stretching it upwards vertically. So it's taking this and it's basically doubling the outputs, right? So that's how I would interpret this in terms of shifts and stretches. Now, let me pause this for a second. And okay, so what I did is I went to the study plan and I found a question that was a good fit for one of the hard ones in the quiz. All right, so very similar. We've got 3 things to analyze. We've got 2 shifts, which is pretty common because the shifts are very easy to see, and so that's a nice way to think about it. And then we've got a negative outside, which remember is times -1. That's a flip. Okay, so we're going to analyze this in terms of the 3 things I see. Number 1, I see times -1. I see -3. I see +3. This is outside. Again, the parentheses mark the boundaries of inside versus outside. Okay, that means that this has to do with vertical, and horizontal. Okay, and then this means that it's intuitive, and counterintuitive. Okay. So, last one, I guess, write down is this a shift, this is a shift, and this is a flip. Okay, so I'm ready to try to do this, and I'm going to do it with my graph here. Okay, so the first thing is to put the vertex on, I think, although I tried to do this the other time, and I'm not sure it worked. So let's see if I get the vertex in place. I want to do a counterintuitive shift horizontally, -3. I would think -3 would go this way, but since it's counterintuitive, I'm actually going to go this way. And then outside vertically, I'm going to shift vertically 3, so I'm going to go up 3. All right, see, I put it there, but it didn't go there. So anyways, I got to do my shift tool. I want to go here, and I want to go here. Okay, so this is where I think that the vertex is. Now, I notice that I have a negative outside. That's a vertical flip. A vertical flip. Now, one of the nice things about the way they've written this here is that the left side is vertical, the right side is horizontal. So you don't really have to think too hard about this reflection. I was kind of thinking hard about it earlier. I was like, oh, wait a minute. Everything on the left is vertical. Everything on the right is horizontal. So this is the one that I want in terms of flip. It's a vertical flip. A vertical flip is actually a reflection about the x-axis, which is kind of confusing. Okay, now one of the interesting things about transformations is that the order actually matters. You can't just ignore the order and do it whatever order you want. So just to make sure I haven't made a mistake here, I'm going to try a number and I'm going to see how it turns out. For instance, I see that there's a point here which should be like 4 minus 4. Let me see. Put in 4. Oh, and I missed the cubed. Shoot. I'm actually doing the totally wrong thing. Let's just pretend this is x squared. We could talk about x cubed here in a second. Yeah, okay, so this is x squared. All right. So what I'm doing right now is I'm trying to imagine, is the point 4, -4 on here, right? If this was a quiz, then I can't just check my answer. I've got to be confident before I move on. So I plug it in, minus 4 minus 3, because that's my input, squared, plus 3. That's going to be minus 1 squared plus 3. So that's minus 1 plus 3. That's equal to 2. This is not correct. And the reason it's not correct is because I did my vertical shift before I did my flip. But the impact of that is that I've mistakenly got this in the wrong place. Okay. Now you can kind of think about it with the order of operations, like if I wanted to flip after I did a shift of up 3, which is what happened, right? We had this thing, it was up here, right? And then we flipped it over the x-axis, so now we're down here. That would be more like this, x minus 3 squared plus 3. Because the negative then would flip that, and it would flip the plus 3, which would actually take it down 3. But that's not what I wanted. I wanted to actually flip it and then move it up 3. So I need this. I need to go back to my tool, basically, and I need to make sure that this, give me that, there it is. The vertical shift is actually a plus 3, because when I did the check, it actually flipped it, right? And now I can see that I would be in the right place, because, let me go back to my annotation. Because if I label this point, it's 4, 2, and that's what I ended up with. When I plugged in 4, 4 minus 3 is 1, 1 squared is 1, minus 1 plus 3 is 2. This is the correct point. So what I'm saying is there's a way to check that your work is right. Now, if you're totally lost, then there's no way to just fake it and get it right. But using the structure I've given you, which is outside-inside analysis and then layering it on intuitive, counterintuitive, it can help you build the right transformation, and then you can use inputs and outputs to check to make sure your work is good. Let's clear all of that and go back and acknowledge that actually it was doing the wrong problem, because that's cubed, not squared, which, you know, sorry. Yeah, I want to clear that. Okay, so I go to cube, start in the middle, right? I'm going, so what I maybe should have done, go from the inside out, then I don't have to do this kind of switching thing. So going from the inside out, the first one is minus 3. It's inside, so that's horizontal, but it's counterintuitive. So minus 3 is actually plus 3. So it's a horizontal shift of 3. Then I'm going to do my flip, whoop, and then I'm going to do my vertical shift. So inside to outside is going to be the best way to do a transformation and not have to worry about it. But let's check. Okay. So I'm going to take, well, that's actually the exact same number, which shouldn't be surprising. Here, let's try a different number. Let's try this one. So we're going to go annotate here. All right. So I'm seeing that what looks like we should have a point here at 2, 4. Okay, so put in minus 2 minus 3 cubed plus 3. So that's minus 1 cubed plus 3. So that's minus 1 plus 3. So that's plus 1 plus 3. It's equal to 4. Boom. Check my answer. I bet you a nickel that I'm right. I'm going to get rid of that. Get rid of that. Check it. Hey-o. Okay. So bottom line, working with graphs and domain and range, just, put some time into it. Lots of stuff is confusing about that. Not least of which is all the interval notation and making sure you feel good about how to express those things. So, if you do the quiz the first time and it doesn't go well, don't just jump right back into it. Why don't you look at the problems you got wrong, send me some screenshots, and let's talk about what you're confused about. All right, guys, work hard. Talk to you later.